So the big idea behind this lesson is we have already made the connection between parallel lines cut by a transversal resulting in all 5 of these conclusions, right? If we have parallel lines cut by a transversal, then we can conclude each of these things. We can conclude that alternate interior angles are congruent. We can conclude that alternate exterior angles are congruent. And we've got all these conclusions that we came to in our previous lesson, right? Now the thing about this is, if we find, or if we are told that we have 2 angles that are congruent, and they happen to be alternate interior angles, well then we can go the other direction with this, and we can prove that parallel lines are cut by a transversal, or the key there would be that the lines are parallel. So if you're looking at a picture and you're sort of not sure, maybe I'm just freehand drawing this here, and you think those lines sort of look parallel. I'm not really sure if they are, but you're given information here. Let's say we have 2 angles, 1 and 2, and you are given that angle 1 and angle 2 are supplementary. Well, that's enough for you to then prove that these 2 lines are going to have to be parallel, because these 2 angles here are same side interior angles. So if you have same side interior angles and it turns out that they're supplementary, well, the only way that that's possible is if those 2 lines that were cut by the transversal are parallel. So this lesson is just about us taking these conclusions to prove parallel lines, rather than being given parallel lines to make these conclusions. It's the opposite of our previous lesson. So the first couple of proofs are really short, and I'm going to go ahead and just set these up so that you can see we've got our statements and our reasons. All right, so they've told us in the first proof that A is parallel to M. So it's a good idea to annotate the diagram and show that you understand that those 2 lines are parallel. Now, from what we know about parallel lines cut by a transversal, we have all these conclusions that go along with that, like corresponding angles are going to have to be congruent, alternate interior angles are going to have to be congruent, same side exterior angles are going to have to be supplementary, and all these things that we now know are true. So if it turns out that 3 and 6, these 2 angles that we're investigating, are one of those special angle pairs, well then we're all set. So I'm trying to prove that angle 3 and angle 6 are congruent, and that's great news because I can already make that claim. I can say that angle 3 is congruent to angle 6 because I have parallel lines, and I can classify those 2 angles as alternate interior angles. So if parallel lines are cut by a transversal, and that's what we've got here, right? We've got parallel lines A and M cut by transversal T, then alternate interior angles are congruent. Very short little proof. All right, it's just simple because it's sort of reminding us of that conclusion that we came to, where if we're told that we've got parallel lines, we can conclude any of those 5 statements. All right, so that proof is finished. Now the proof below it, the second proof, is sort of the reverse, right? So you've been given that angle 2 and angle 7 are congruent. And based on that, I'm asked to prove that these 2 lines are parallel lines. And this is the point of this lesson, right? It's that I can do this now. So I can say that line A is parallel to line M, and my reason is the reverse of that reason that I just gave. So it turns out here that we've got alternate exterior angles, and if alternate exterior angles are congruent, well, that's the exact opposite of the reasoning that we used in the previous problem. In that case, we were given that lines were parallel, and we were asked to prove that we had 2 congruent angles. And in this case, we're given 2 congruent angles, and by classifying them into one of those angle pairs that we've discussed, we can make the conclusion that the lines must be parallel. So if alternate exterior angles are congruent, then the lines cut by the transversal have to be parallel. Okay, so this proof at the bottom here is going to take us just a little bit more time. And this time we're given two statements. We're given that L and M are parallel, so that might be useful. And we're told that angle 1 is congruent to angle 2. So those two angles are congruent, and L and M are parallel. And what we're trying to find here is that A and B, these two lines, are parallel to one another. So I'm going to use two arrows to show that those lines aren't parallel to the other two lines. So what can I do with this? Well, I'm sort of thinking backwards, thinking about how in the last proof I was able to prove that these two lines were parallel by finding one of those special angle pairs on the transversal that cuts those two angles. So here I have my lines A and B, and I have two transversals that I could say are cutting through A and B. I've got this line L, and I've got this line M. And I'm going to want to focus in on line M because line M is the one of the two transversals that has two angles on it. And I'm noticing that those are alternate exterior angles. So if I can show that these alternate exterior angles are congruent, then that will tell me that these two lines have to be parallel. Now, how's that going to work? Well, if I know that 1 and 2 are congruent to each other, then all I have to do is find a way to prove that 3 is also congruent to 1. That will allow me to attach the congruence of 3 to 2 as well. So you'll see how we'll go through this here. It's not super long. It's just a couple steps. And we'll start with the idea that line L is parallel to line M. That's given. Now, if those two lines are parallel, what I can do is just sort of pretend that I don't have that bottom line and focus in on that top line, right? So if I really take a look at that there, I can see that these are my parallel lines, and this is my transversal, which would actually make these two angles corresponding angles. They're in the same exact location of their respective intersection points on this transversal. So what I can do is say, don't want to change colors there. I'm going to say that angle 1 is congruent to angle 3. And the reason that I know that is because when parallel lines are cut by a transversal, corresponding angles are congruent. Okay, so I'm starting to make this work here. I've now proven that angle 3 is congruent to angle 1. So again, I'm just using the one arc there. What I need to do now, though, is connect 3 to 2. And I know that this is true because they've given me the given statement that angle 1 is congruent to angle 2. And our reason for that can just be given. So now we've got this chain of congruence, right? I've been told that angle 1, well, let's start with angle 2 is congruent to angle 1. They gave us that. And then we just went out and proved that angle 1 is congruent to angle 3. So what I'm going to do is just sort of get rid of this middle statement and say angle 2, it has to be congruent to angle 3. And my reason for that is just going to be essentially the substitution property, which has a more formal name. But right now we're just going to think of that as just like all of the substitutions that we did in some of our earlier equality proofs. So that's the substitution property of congruence, right? We're not talking about equality here. So finally, I can sort of look at these as all being the same. 1, 2, and 3, they're all congruent. They all have the same angular measures. So now, just like we discussed, I can see that I have alternate exterior angles that are congruent. And if I have alternate exterior angles that are congruent, then that means that the lines intersected by that transversal are going to have to be parallel. That follows the conclusion that we came to in our previous proof as well. So I'm going to make the conclusion now that line A has to be parallel to line B. And my reason is going to look just like this reason, except instead of saying, well, no, it is that reason. So again, if alternate exterior angles are congruent, then lines cut by the transversal are parallel. And you could think of this reasoning right here being swapped out for any of the other four conclusions we came to about angles created by parallel lines and transversals. That could say if alternate interior angles are congruent, or it could say if corresponding angles are congruent, or it could say if same side exterior angles are supplementary, right? So if it's any one of those conclusions, then we can use that conclusion to prove that we've got two parallel lines.